Okay, last example. Happy or sad? I won't ask. Bittersweet, I'm sure. So sine 2 theta equals cos x minus 45. Now, what we ended off the last video saying was, let's try and make sure that we just got sines or just got causes. So we're going to use that idea from our freestanding triangle, that if that's theta and that's 90 minus theta because of right angle triangle, right? That sine theta is the same as cos of 90 minus theta. And conversely, cos theta is sine of 90 minus theta. Right? That idea should hopefully be sticking in. It's one of our co-ratios that we just use offhand. So if sine 10 is cos 80, that type of idea. Cos 20, sine 70. So you can do this either way. We've got sine 2 theta equals cos x minus 45. You could either change the sine into cos or the cos into sine. Now, I don't know why. I'm just going to go for this and say that cos 2 theta, or sine 2 theta rather, is cos of not 2 theta anymore, but 90 minus 2 theta. And apologies, this should have been a theta, otherwise we definitely have no hope here. So sine 2 theta is the same as cos of 90 minus 2 theta. And on this side, we could leave it as cos of theta minus 45. Alternatively, what you could have done is kept this as sine 2 theta and changed the right hand side to sine and gone 90 minus that angle there. Now, this is why I went for the first option, because I worried about 90 minus. Now I've got brackets and brackets, more brackets and brackets and minus. I mean, at least the 90 and the 45, at least we just have theta. So minus theta minus 45. So that's 90 minus theta minus 45. Well, that's just minus 135. 135 minus theta. I think we're right, but maybe that would work better for you. But maybe you can see why my idea was, maybe it's just safer to go for the first option as we did. So we didn't have to worry about those minuses, or are we subtracting the whole angle? Okay, so let's get rid of that doodah there. And let's just put that in its box. So now we've got cos something equals cos something else. So it feels like, well, that's easy enough. 90 minus 2 theta equals theta minus 45. Well, that's part of the puzzle. But let's just revisit our cast diagram. Whenever we had some sort of reference angle, we said, well, wait a second. We looked there and we went CAST, and we said, no, but wait a second. There were always two solutions. So if cos was positive, we would have gone there and there. If cos was negative, we would have gone there and there. So let's say that both of these are positive, and we'd be there and there. So this first solution is almost like the one that relates to the first quadrant. But there must be a second solution, and that is, how do we find the second solution in this fourth quadrant? And that is, we would say, well, 90 minus 2 theta is the same as 360 minus whatever theta is. So it would be 360 minus whatever theta is. And that would give us our second solution. It's just that theta was this bit here, or our reference angle. So, as I said, think about that as if your reference angle was 30 degrees. You would have said, well, we've got two solutions. Either theta is 30 degrees, or we would have moved into the fourth quadrant and said theta is 360 minus 30 degrees. It's just that instead of 30 degrees over here, instead of this 30, we've got theta minus 45. So there's the one solution, or it's 360 minus our 30. Okay, interesting ideas, right? So there are two solutions. Now remember that the cos graph repeats itself every 360 degrees. So plus 360k or k times 360. And now we just solve our little equation. So we've got minus 2 theta. I'm going to subtract theta from both sides. I'm going to subtract 90 from both sides. So I've got minus 90 minus 145 minus 135. I've still got my 360k. I want theta. So I'm going to divide everything by negative 3. So I think that's going to give me 45. But, let's just check these things. 135 divided by 3. Oh, not minus 3. 135 divided by 3 gives us 45. So 45, and this divided by 3 would be 120k. Now remember that k is an integer. So that's why I haven't written this as minus, because k can be positive or negative. So it just looks a little neater to go plus 120k. So there's our one solution. And for our second solution, we've got, again, let's just maybe simplify this and not try and do too many steps in one. Maybe you're comfortable with it. I like to see where I may need to or could easily make a mistake. So I'm going to add theta to both sides. I'm going to subtract 90 from both sides. So we've got 360 plus 45. Well, we've got 360 plus 45 minus that 90 gives us 315 plus 360k. And divide both sides by negative 1. So theta equals minus 315 plus 360k. Again, k is an integer, so we don't want to say minus, it would say the same thing. Now, sometimes it really doesn't matter. Minus 315, if we add 360, we should be at our second solution. So sometimes it just feels neater, although that's as correct, that we put an acute angle or we put a positive value here and say, well, those two, this and this are saying the same thing, but the second one just looks a little neater. Doesn't matter though. So we've got our two solutions now. And those two solutions, there's the one solution, and our second general solution is that. Now, if we pause for a second and just look at these, 45 plus 120k and 45 plus 360k. They're half saying the same thing. So if we've got 45 and we add 120, cool. Let's just have a look at what that is actually. So 45 plus 120, where's our next solution? Plus another 120 and plus another 120. Wouldn't that just be the same as adding 360? So as it so happens that in this case, our first solution covers everything we need. But we had to look for both just in case, because it just so happened in the example that we've chosen here. Okay, so leave them as both. That was just a nice little extra sting in the tail in some ways. So with that, enjoy worksheet P. Make it nice.